Okay, myself, Uchit Vyas. I'm a senior consultant over in Attune Infocom, and today we are starting with a continuous delivery webinar series. Okay, so yeah, I will starting. I will just give you some demos and show some PPTs. So first of all, I will very much thankful to you that coming over from here. I was expecting some few participants, but there are many participants out here. So I'm glad to hear this. Now, so the basic term continuous delivery. So before jumping into the continuous delivery, let's I have to ask some questions that what are the problem of delivering the software? Okay, when we are creating some applications or software, custom softwares. So what are the basic problems? Okay, so let you introduce some problems and then we are just jumping into the continuous delivery. Okay, so the most important problem that we face as software professional in this is if somebody thinks of a good idea and how do we deliver it to users as quickly as possible. So we focus on the build, deploy, test and release processes, about which relatively little has been written. Okay, so this has not been because we think that software development approaches are not important, rather that without a focus on the other aspects of the software life cycle, like we can say aspects that are all too commonly treated as a peripheral to the overall problem, it is impossible to achieve reliable and rapid low-risk software releases that get the fruits of our labors into the hands of our users in an efficient manner. So there are many software development methodologies, but they focus primarily on requirement management and its impact on the development effort. Okay, so there are many excellent books also available. We can say for continuous integration, continuous delivery, good practice in a continuous delivery. These kind of books are also available. Okay, so there is definitely there is some pattern in the particular books, we can say. So what happens once requirements are identified, solution designed, developed and tested? Okay, how are these activities joined together and coordinated to make the process as efficient and reliable as we can make it? And another thing is, how do we enable developers, testers, build and operations personnel to work together efficiently? So the pattern that is central to this is deployment pipeline. A deployment pipeline is, in a sense, an automated implementation of your application's build, deploy, test and release processes. Okay, so every organization will have differences in the implementation of their deployment pipelines depending on their value stream for releasing software, but the principles that govern them do not vary. We can say there is a if we talk with the deployment pipeline, so there is a commit state. We can say next is in automated acceptance testing, next is automated capacity testing, then manual testing, and then release. So in a commit state, there is a, we can say, compile, unit test, analysis, and build installers. So these are the phases for the particular stages. Okay, so the aim of the deployment pipeline is a threefold. We can say first, it makes every part of the process of building, deploying, testing, and releasing software visible to everybody involved, aiding collaboration. Next is it improves feedback so that problems are identified and so resolved as early in the process as possible. And finally, it enables teams to deploy, we can say teams to deploy and release any version of their software to any environment that will through a fully automated process. So we can say what are the some common release anti-patterns which should not be done. So we can say the day of software release tends to be a tense one, because why should this be in the case? For most projects, it is a degree of risk associated with the process that makes release a scary time. In many software projects, release is a manually intensive process. So the environments that host the software are often crafted individually, usually by an operational or IS team. So third-party software that the application relies on or installed, the software artifacts of the application itself are copied to the production host environments. So this is the first reason. The reason for the nervousness should be clear. There is quite a lot to go wrong in the process. If any step is not perfectly executed, the application won't run properly. So at this point, it may not be clear where the error is and which step went for error. Next is deployment software manually. Of course, the production is of extensive detailed documentation that describes the steps to be taken and the way in which the steps may go wrong. So we can say reliance on manual testing to confirm that the application is running correctly. These are the steps that all the traditional manners we are following. Next is environment in the cluster that differ in the configuration. For example, application servers with different connection pool settings, file system with different layouts, etc. Okay. So instead of let's start with this basic PPT slides. I'm sharing my screen. Yeah, so start with the continuous delivery. Yeah. Okay, so these are the typical project what we are following in a traditional manner. You can say first stage is requirement, then is design, development, queue, and release. So we can say when our business developments are go with the analysts and customers, or we can say they are gathering requirements, they are putting with the architecture, and they are designing the themes. Then they are putting in a development stage, and after that QA come in a picture, and then the release. We can say operation team. So the basic we can say normal model which we are following in a traditional manner in this world. Okay. So we can say waterfall model. Yeah, definitely. All have learned in the educational curriculum pattern that waterfall model and all this different models. So basic problems with this chain cycle, this we can say deployment cycle. We can say test, release, and deployment. Okay, so we can say long QA feedback loop, because whenever the feedback comes after the testing scenarios has been passed from the QA team, then and then developer can move ahead. We can say lack of collaboration, because development team is doing development on and on. Testing teams are testing the different modules as per their availability and all this loops. Next is production team deploying all the acceptance tested modules one by one, but there is not any kind of we can say collaboration. So this is the main another problem is lack of collaboration. Next is inability to change the direction, that we can say if we have defined some cycle that we will start with this phase, we will then test it, and we will then put in a production manner. So in this case there is a one rigid direction is there, but we have to be flexible in this case, because if we get some error, or if you are having some issues with the server, or we can say if you are having some issues in a development stage, then what will happen? We can say definitely the time wasting will be happen. Definitely your resource management will be not good because of these issues. So these are the basic problems with the waterfall models that everyone is facing right now. So if you are putting this a waterfall model project, okay, so these are the basic life cycle that from requirements gathering to QA, it will come as a months, come in a months, and then after the months it will start some we can say release things after some months. So it will very time consuming process. Okay, so, but it should be agile. Okay, so agile project in the sense whatever we are developing, whatever the team is giving the requirement, or whatever the customer is giving the requirement to you, it will immediately developed, it will immediately tested, and it should be immediately developed to the end user, we can say for customer. So this way, if requirement goes change at any kind of scenario or any point of time, we can directly get back the requirement, and we can again reproduce the as per the requirement. Okay, so these are the we can say these things, or we can say module wise development we can put in a development side, or we can say life cycle of the project we can cover in a days, not less, not in a months. Okay, so last mile we can say we should avoid manual deployments, insufficient configuration management, and error prone deployments, in the sense whatever the tools you are using for your deployment, or whatever your tools that you are using for the testing purpose, we should enhance the tools, or we should integrate some automated tools with these things, so that we can get where our deployment is going on a wrong manner, where our test scenarios are going in a wrong manner, or where our development is going in a wrong scenario. Okay, yeah. So again, whenever the release time is come, it is a very stressful for every developers or every testers. Okay, and definitely this pictures tells everything to you. So what is next is what is continuous delivery. Let me give you the basic definition. We can say building, testing, and releasing a software faster and more frequently. This means continuous delivery. That's it. This is the basic definition for a continuous delivery. It is not a continuous integration. I'm saying it is continuous delivery. Okay. So the main goal is continuous delivery for better quality and less cycle time. Okay. And yeah, definitely, what is definition of done? If you are a project lead, or if you are a project head, or if you are a project manager, okay, or if you are an architect, then definitely you have to define what is the definition of done for your project or for application. We can say automatic deployments. Okay, so first of all, we should start with automated deployment. No one should be very much busy with the deployment life cycle, that if the code is coming to towards the person and he will just deploying all the things. That should be not happen. Continuous in the sense, whatever you have developed, whatever your developer has developed, okay, it should be integrated properly within a continuous manner. Then whatever the developer is developing, it should be delivered continuously. Next, whenever you have delivered some modules, or we can say some chunk of code, it should be deployed automatically. Okay. So these are the things. This is the basic things. What is continuous wordings. Next is, yeah, this is the flow architecture. Whatever we can say continuous deployment, the first step. Next is build pipeline. Third one is deployment automation. And apart from deployment automation, there are three things are there. We can say testing, integration, and management. And the lower block is agile things. Okay, the short should be agile, and it all should be tested, integrated, and well managed. And then we can directly jump into the deployment, or we can say automated deployment. Then we can start deployment pipelines, so we can say build pipeline. And after the release phase, we can say that we have done with the continuous deployment. Okay, so this is the basic architecture for continuous delivery of a flow architecture. Okay. So configuration management, what is it? It means versioning the code. If you are developing some code, after some time, if you are patching the code, if you are providing the another updation of the code, then that means it's versioned. Next is single identifier, dependencies, application configurations, data, and environments. All things should be managed. That means configuration management. These things are come in a configuration management section. We can say dependencies, it should be managed well, or we can say configurations or environment setup, it should be managed, because if you are, we can say, if your developer developed a code in a Windows machine, and definitely our production server is on a Linux machine, then it should be deployed correctly, and it should work properly, and after the passing of all the acceptance tests. Okay. Next is continuous integration, definitely. So this is the stages of CI. We can say continuous integration. So whenever you are starting with the development, every day your developer should check in the code in the repository, or if the developer should commit the code in the trunk, or we can say they have to manage the releases to the trunk. Then they have to automate the build cycle. Whatever they are developing, it should be in a deployment phase, and keep the build faster. Don't push the don't come every day and push the code in a trunk, and after the week, or we can say on a Friday there is a go where cycle. Don't do that thing. We can say do deployment every day. Whatever the deployment whatever the code you have developed, it should be deployed, it should be tested, and it should be released to the end user. So at any time of point, the end user, or we can say customer, can check what is the deployment, what are the things they are getting, what are the code they are getting, what are the effects of the that product they are updating. Okay. So next is every commit results in a build, definitely, and test in a clone or production environment. Never go directly with the production environment. First of all, create one clone environment of your production cycle, and then deploy that code as the production cycle, and then deploy that original code in a production environment. We can say if you are doing some, we can say dev, test, and production environment, but you should have 4 kind of environment. We can say clone of a production and a production. Next, after the last step is automated deployment. You should go with that thing, automated deploy. Don't deploy the code automatically on only a production server. The people are doing what thing they are doing. They are putting that the code in a development server. They are testing over there. Then they are providing the code to testers. The testers will test it on the test server, and then it will provide to the that operational team. Operational team will test on the local machine, and then they are providing the code to the production team that they will do a production on a production server. This is not the ideal case or ideal scenario to do a deployment. So recommend practices are every user are right now doing a programming on a Windows XP, or we can say a Linux machine. So do that kind of scenario, that fail a build for design breaches. Just design that kind of code that it is failed. It is come in a failed manner. Okay. Next is design your test that will come in a failure tests, and design your code style or warning that will come to in a, we can say code is your code is false, or we can say design is in a that erroneous design, or we can say erroneous code is there. And breaches your cycle, we can say deployment, breach your deployment cycle, breach your testing cycle. Do these things for a best practicing to test your code. Yeah, next is testing. So different types of testings we can use in automated deployment, or we can say continuous delivery. The first is definitely test the our code is a unit testing. Next is integration tests, functional acceptance tests, and how our application is working, or how the application is behaving in a production environment, or we can say in a test environment. That is a performance and load test. And next is penetration test, and the last is a exploratory test. The last two are the, we can say, not mandatory, but above fours are very mandatory, because the performance test and load test should be there, integration test should be there, and unit test should be there. So how can we define the testing strategies? Okay. So first of all, you have to identify what is the project risk, what are the priorities of the project risk. Then about that priorities, what action should be taken. Okay, you have to define these things, and then we can say whatever the test scenarios you are writing, what will be the effect of that test scenario. You need to be confident about that thing. So these are the basic phases. Definitely this is the basic image. You can find it on a Google also. Okay, so first of all, we can say start with basic tools. We can say performance and load testing, security testing, and some kind of testing. Or we can say if you are doing with first of all, you start with unit test to test your code, component test to test your chunk of code, to test your component, to test your packages. Then come with a automated and manual test, in the sense functional test is how my code is working as its functional behavior, how my stories are, how we can write a story for testing stories, how we can define prototypes and simulations. Then come to manual testing, in the sense user acceptance tests. We can say our UI kind of testings, or we can say exploratory testing scenarios, or whatever it is. Next, then after it will come in a performance testing and load testing, how my application is working. Okay. So recommendation is basically definitely automate your test. Use fakes and mocks IDs and mocks, we can say fake codes or unusable codes and all these things. Automated acceptance testing, definitely you have to write some acceptance test scenarios and acceptance test stories to test your code or application. So what will be the benefit? We can say fast feedback you will get. You can definitely reduce your tester workload, and tester can do exploratory testings, or we can say regression test they can do. Requirements can be generated from test. Definitely if you are getting some errors during the test life cycle, you will get the better idea how our code is working, and how can I do that we can say enhancement about that code, and how can I change the requirement particular as per the behavior of the test scenarios. Next is acceptance test approaches. We can say test driven development, or we can say behavior driven development. There are cold war is going on within this test driven development and behavior driven development right now. Okay, so there are pretty mature tools are available for test driven development and behavior development also. Okay. So kind of toast in the sense, given some preconditions, we can say if this happen, when some event is occurs, then do these things. These are the basic things. With this kind of scripts you can write in a test driven development also, and business behavior driven development also. We can say if you are writing with a Cucumber script or a JUnit RSpec scripts, okay, you can use this kind of scenarios and this kind of scripts. So deployment automation. So first of all, start with the version control. Everyone starting developing the code and pushing that code in the repository, it should be versioned. So it should be managed by the, we can say, Git or SVN, what you are using, SCM tools, and it will come with the, we can say, if you are building the artifact repository to to specifying the releases, then you can put over the artifact repository. Then it will come into database layer and application layer. Whatever the code you are developing, it will come in a, we can say, application layer. It will consist of application, configuration, middleware, and operating system. So your code should pass all these scenarios. We can say it should be very much mature about for operating system. It should be mature for your application. It should be mature for your configuration. And definitely, after all, whatever the things you are developing, it will go in a backend as a backend in a database. Okay. So appropriate technology. Use appropriate technology when you are starting with the new development. Think about it. Which kind of technology I can use to better enhance my application. We can say if you are starting with a portal development or whatever, if it is a Java based or a PHP based, but it should fulfill all your requirements. Next is scripting approaches. Okay, so whenever you are starting with a scripting approach, so script should be equal or should be parallel for all the your scenarios. We can say if you are starting with a test scenarios, or we can say in a deployment scenarios, it should be unique. It should work on every machine. We can say locally and remote machine also. So, and next is this third point, package app using platforms packaging technology correctly. As per the platform, you need to define that package. So infrastructure management tools can push that new versions as fast as possible. Next is database deployment. Again, version of your database is it should be very much matured. It should be stable. It should be clustered, and you should evolve your database incrementally. If you are, we can say, I have configured I have configured my database, and that's it. I have clustered my database. That's it. This is not enough in a real-time scenario. You have to evolve your database incrementally. We can say after 2 days or 3-4 days or a weekly. Next is environment management. Definitely, version and application configuration. Your application should have definitely at every time of deployment, it should be versioned, and version your operating system also. You should take the basic production system backup also, and you should monitor your operating system as well as that configuration files. So if you are going with the deployment in the cloud, okay, so build the pipelines. And right now we can say cloud computing is a buzzword right now. Okay, so everyone is going to with the cloud because it's a secure, reliable, and agile. Okay, so build your pipelines. So for your, we can say, build pipeline, automated manifestation of your process. Okay, for getting software from version control into your end users. So we can say, what are the synonyms for that thing? This is a deployment pipeline, or we can say living build, deployment production line. These are, we can say, all are building pipelines. So this is the stages. Yeah, this is the basic stage for the pipeline. We can say developer is developing the code, it's committing the code and come to the testing scenario. It will start with the acceptance testing scenario, or we can say then is a presentation manner. Then again tester will come in a picture for manual testing. If the manual testing is completed, then it will come in a product owner stage. We can say it will manual, we can say it will again manual testing scenario. We can say product owner will test all the functionalities and features whatever the developer has developed, and then it will come in operation team, and then it will come in a release cycle. So these are the different tools for version controlling. You can say Subversion, Git, or Mercurial. You can use these things. Right now Git is very much famous, and we can say you can use that GitHub or Gitorious account, which are very much publicly available. Okay, so another things very much many people are using this kind of dependency management. We can say Nexus repository and Artifactory for repository builds and release management things. Yeah, definitely these are the best tools we can say for infrastructure management, Puppet and Chef. Again, for continuous integration and continuous deployment, you can use that Jenkins, Hudson, TeamCity, Cruise Control. These are the things you can use for automation and continuous integration. And build automation, definitely Maven is there, Gradle is there, EV is there. Some time ago, people were using Ant also, but right now Ant is nobody is using. Yeah, these are the testing tools. Selenium, the best one for the UI browser-based testing. We can say DB unit testing for database testing. Then JUnit testing, you can check your code with this JUnit testing. Acceptance testing, definitely. JBehave is very good for Java codes. EasyB, very much mature tool for the acceptance testing scenarios. So that's it. This is the basic things what we have to start with the automatic deployment. We can say continuous delivery. How we can step ahead with the continuous integration to continuous delivery, and how we can do a deployment successfully. Okay. So I'm just ending this my webinar over here. If you have any queries, you can directly contact us. Okay. And again, this is the basic startup. So after some time, we'll move ahead one step, and we will start with the deployment also. We will start with demos also. Okay. Yeah, you can ask the questions also. I'm giving you chance for these things. First, I will start with this offline. Yeah. So I'm just unmuting the person. If you have any questions, you can ask me. It's Horaichi Velad. If you have any questions, you can ask. Are you there? Okay, I think he don't have any questions. Okay, Manoj Prasad.
Yes.
Yeah. If you have any questions regarding this, you can ask.
How do we do integration? Deployment in a library environment.
So, is your library environment is ready right now? Are you in a production environment right now?
No, not right now, but we'll soon be. So, I would like to strategize as to what is the general way to do that.
Yeah, see, if you are a library developer, okay, then definitely you will know about the library plugins and library Tomcat bundle, correct?
Mm-hmm.
Yeah, so yes. What we can do, we can use Jenkins for these things. You can use Maven, and you can use Git. Okay, so whatever the things you are developing, you should put in a Git repository. Then from Git repository, you should configure your Jenkins machine with that Git repository. Okay, so whenever you are starting with the build, okay, it will fetch all the code from that repository plugins. We can say that is a library plugins. It should be library plugins. It will pull all the code from that repository, and it will put it in your production server or whatever the testing server is there. Okay, using Jenkins. Okay, and you can directly definitely use that SSH also. Okay, at a Jenkins machine, you can integrate your, you can configure your Maven or Ant. Okay, and at that time you can configure your testing scenarios also. we can say if you are going with a Cucumber testing or a JUnit testing, you can configure that thing within the Jenkins also.
How about the configuration data? How to code that?
Yeah, see, Jenkins has a very much mature plugins also available. If you are going with we can say JUnit testing, if you are going, okay, so there is a JUnit plugin is there. You have to download just JUnit things in your server, and you have to configure it with Jenkins. It's the simplest thing is that we have to just give the path of our configuration, or we can say configuration file to the particular Jenkins in text box, and then it will configure automatically, and you can start your deployment.
Okay, no, the question was basically, suppose there is a library project, have number of static pages, say,
yeah,
for example, static dynamic pages,
yeah,
and all that configuration is there inside the MySQL database. Now that database, its configuration along with all the user configuration need to be put it to the testing environment, stage environment. So how to automate that? I mean, is there any recommended strategy?
See, if you are using that configuration things at a database side, okay, but database side, what we are storing, what kind of data you are storing in a database apart from liferay? If you are,
I mean, basically the page data, all the web content, say all the workflow related data, all those things.
Storing these things into database, it's not a good practice, first of all. Okay, because if your database connectivity is lost, if your database server is down, or if your production server is going down, what will happen? You cannot provide the continuous things with your application, or we can say your portal goes down, definitely, because of this only a thing of database. The good practice is your database should be clustered and should not put this content, or we can say web content things, or we can say users details things into database automatically, everything. You should part it, we can say some database information definitely goes in a database, but some kind of, we can say, web content, it should be in a clustered environment. We can say web content things, or we can say images things, this we can say front end side, whatever the images you are storing, whatever the web content you are storing in a liferay portal, okay, it should come in a, we can say, shared folder, or we can say some shared server.
Okay.
Yeah.
No,
because
that's fine. I mean, we can put it in a shared folder. But my question is kind of specific. See, liferay database will have so many different tables, right?
Yeah, there is non-linear database. Yeah.
Yeah, if we configure in the database and not use the H2 database, we are using MySQL database. So
good. Okay.
There's so many different tables. Some of the all the configuration which we do on the front end using means the design of the web page and all those things, the tabs and all the web content and everything, that need to be put from one to other without manually configuring in each environment. So how do you do that? I mean, do you?
Yeah, for that thing we are modifying that portal properties file also and portal HT properties file also for changing the we can say for storing the data. By default, it is going in a database. Okay.
Right.
But what we are creating, what we are just customizing that portal HT properties and portal properties files to change the liferay's behavior. Okay. Right. Then we are putting in a production environment. Okay, and again, if you have some specific questions, see, if you have some kind of a specific requirement about the database things, I can definitely get back to you within the email. I have the documentation available for these things, so you can go through it. Okay? Yeah.
Right.
Yeah. So just shoot an email for these things. I will get back to you. Okay?
Thanks.
Yeah. Yeah, Mr. Raja Roy. Hello. Hello, Mr. Raja. I think he's gone offline. Yeah. Rajnish Sharma.
No question.
Yeah, fine. Okay, Mr. Narayana.
Okay. No questions.
Okay, fine. So that's it. Here I'm ending my webinar, and if you have any still doubt after the webinar, you can shoot an email to us. Thank you.